Hello, welcome to video 31. This video is going to be on water pollution, and we're going to start with this picture. This is a picture from 1969 of the Cuyahoga River, which is in Ohio or in the Cleveland area. And so what happened is this river was so heavily polluted that it famously caught fire. And there's even a song, you can YouTube the song, it's pretty entertaining. But this really sparked this movement into cleaning up our water supply and trying to do what we can to improve these waters and a push towards making them fishable and swimmable. And so this is 1969 Cuyahoga. The chemicals in there ignited and caught fire and burned for several days. Modern day Cuyahoga looks like this, and so we have made this nice effort, and it's no longer quite the dump that it used to be. You can see there's even fish here. People are using it for recreation. So water pollution is defined as any substance, and that substance we'd call a pollutant, that is going to decrease the water quality, something that's bringing it down. And so there are three main categories of water pollution. We've got point sources, which is pictured down here. Point source is literally a pipe where we can see the point where the pollution is entering the water. And so this is a sewer pipe that is emptying straight into this body of water, and we can locate that point and identify it. The point sources are very easy to place the blame and stuff, and so we've got modern laws and regulations on what we can and can't put into the water system. These point sources are very easy to make lawsuits on or state your cases on it and place blame and who's liable and going to pay the damages, because we can see the actual pollution leaving the pipes. A non-point source, such as an example here, where you've got a large region that's kind of all collecting together, and this is, if you can't tell, a parking lot, right? So any substances on the parking lot when it rains are going to get washed down into the storm drains. And so we can't identify exactly where the oil that might be coming from somewhere on this parking lot came from originally. And so it's a lot harder to place blame for these ones and figure out who exactly is responsible for that source of pollution. Another source here is groundwater contamination or pollution. Typically, you're going to see this groundwater pollution with human wastewater, like sewage and stuff. If you have a latrine that's very close to a well, there can be some migration from the latrine and into the well. A couple different water pollutants. And so when wastewater, which is one of our major water pollutants, when that enters the ecosystem and enters the water, the hydrologic cycle, a couple things you're going to see happen. One of them is the oxygen is going to decrease, and the wastewater is broken down by the bacteria. When they do that, they use up oxygen, and we term this as BOD, which stands for biochemical oxygen demand. And so if we measure the BOD of a body of water, we can determine how much bacteria is in there breaking down how much waste. And so a really good healthy stream would have about 1 ppm of BOD, very low load. Something like raw sewage here in the United States would have about 400 ppms of biological oxygen demand. And so there's a pretty wide scale here, but we want to be very low, about that 1 ppm. If it gets too high, we can cause some dead zones. And so the first picture I have here are dead zones around the world. These red dots are marking where a dead zone exists. What happens with the dead zone is there's so much bacteria that BOD is so high that there is not enough O2 left in the water for fish and crabs and other organisms that might use it. And so it's actually similar or referenced to be similar to walking on the surface of the moon, because there's no life at all in these dead zones. There's no oxygen there to support any life. This is kind of an up-close view of it. If you look at that previous map, each of these dead zones typically lies at a major river runoff. And so this is Louisiana, and the Mississippi River exits and enters the Gulf of Mexico somewhere up here and kind of flows down around. And so there's a pretty well-known dead zone about the size of the state of Rhode Island in the Gulf of Mexico that's due to all that runoff, all these non-point source runoff from farms and industries along the banks of the Mississippi that collect down here and are causing this dead zone. There's a lot of waste that's being broken down here, and we don't have any kind of life. There's no oxygen left. Another type of water pollutant are nutrient pollutions, and we've kind of talked about this extensively. Eutrophication is too much of a good thing, and if you have too many nutrients, typically nitrogen and phosphorus, then you can get these algae blooms. Here's the St. John's. I think this is somewhere in the Mandarin area. where you have an algae bloom. The problem with the algae bloom and these excessive nutrients is that some of the algae is going to be covered up by other algae, right? You've got algae on top of algae. That algae below doesn't receive the sunlight it needs to survive, and so it'll actually die and be decomposed. And similar to our oxygen loss here due to that excessive waste, we're going to result in dead zones with eutrophication, where there's no more oxygen left. Then the last big one here is disease. The E. coli up here is kind of our indicator species for disease. And so E. coli is a bacteria that's found in animal waste. Human waste would be included in that. And we can do a coliform test, a fecal coliform test, which would tell us if there are E. coli bacteria present. If we find them, then we would expect to find other bacteria that could cause things like giardia or polio, even that would be a virus. Cholera, dysentery, a lot of the diseases you suffer playing the Oregon Trail come from water pollution, and typically it's from these waste containing bacteria, right? Animal waste, human waste containing bacteria entering the water supply. This is a really big cause for concern in some developing countries. This is India here, and this river is kind of the life of this city in the picture, and the people bathe in it. They brush their teeth in the river. They do their laundry in the river. The problem is they also dump their sewage in the river. The pipes just enter straight into the river without any form of secondary treatment, definitely not any kind of UV, chlorine, or ozone treatment. And so there's really high amounts of diseases here due to water pollution. And so it's a concern in a lot of places in the world, especially developing countries that don't have the means for disinfecting their wastewater. Other types of water pollutants are some chemicals and some non-chemicals. And so first I'm going to hit on the chemicals. We can have things like metals, acids. These are typically going to be as a result of mining. The water that's used in the mining process will usually pick up some of these metals and acids, and it can lead to a pollution downstream. And so I've got a slide for that coming up here. Another big one is synthetics. And so synthetics can be pesticides that exist in the environment, like DDT, remember, would be a good example of that. They can also be what I have down here, which is PCBs. This is one we'll talk about later in the hazardous wastes, but it's a really big water pollutant. PCBs are chemicals that were used in a lot of electrical devices back in the early 1900s, but they exist in the environment essentially forever. They don't break down naturally, and so if we have them, they can kind of bioaccumulate in larger species, such as humans or whales and sharks and things like that. And they're carcinogens and then cause cancer, along with a host of other problems from them. Oil would be another one of these chemical pollutants that we can have. There are also some non-chemical pollutants, solid waste. Like this bird here is a shorebird, a seabird, and you can see that over the course of its life, it's consumed bits and bits and bits of plastic. These are solid pieces. They're not physical chemicals. It looks like there's actually a lighter right here inside that bird's stomach that it's eaten over time. And so that's a type of water pollution. Sediment pollution is what I've got in this image. So this would be some large-scale soil erosion, and you can see the color of the water running off that farm. That sediment pollution there is going to affect the water. The sunlight's not going to penetrate this water as easily, and so what you're going to see is plant life will have a harder time surviving. You will also increase the temperature of the water with those sediments, and so it has negative effects. It's reducing the water quality. Thermal pollution, especially here in Jacksonville, is something to consider. These giant cooling towers at a coal plant, like you see on the other side of the river here in town, those are there to cool water that has been boiled in the coal plant. And so this kind of candy cane smokestack is where they're emitting the exhaust, and they burn the coal to heat the water, which turns to steam and spins the turbines, and then they pour that water into these cooling towers before returning it to the environment. It's still significantly warmer than the natural waters, and so that thermal increase is a source of water pollution. This is kind of a case study, a local kind of near and dear to my heart one. This is Skytop Mountain, which is in Center County where I'm from. And essentially what they wanted to do at Skytop is they had to remove a section. You can see how it was removed here. That section they removed so they could build a highway from Altoona to State College, Pennsylvania. And what happened when they removed it is they exposed some pyrite, which is fool's gold, but it contains zinc lead sulfide in pyrite. And so what happened is when they exposed the rock, they also used some of that rock containing the pyrite as fill for the road. You need to crush up rocks to put underneath the asphalt, and so they did that as well. What happened is that exposed pyrite seeped a very acidic substance, pH less than 2.5, and that leachate was getting out because now it's exposed to water, where before it had previously been buried underground. Just like with mining, all these things like the heavy metals over here, the lead, the arsenic, the mercury, those all exist in Earth's crust, but as long as we aren't mining them and exposing them to the water cycle, they aren't really acting as a water pollutant. And so the same thing is the case here. We exposed the pyrite, and now when it rains or when it floods, that pyrite mixes with water, and you can see that acid deposition here on the sides. This kind of reddish water here is the source of the acid runoff. And so essentially to fix the problem, they had to create a lined and covered deposit for the rock material to be sealed indefinitely. And so literally what they've done is they've created a giant cover for this exposed hillside and planted grass and stuff over top of it, but it's to seal it off indefinitely, prevent water from getting down and exposing it. They also took some of the rocks they had extracted already and they covered them up in a separate location. Same process, right? Seal it, protect it, keep it locked up forever, put it back the way that they found it. And so it's a very expensive process to do, but something that needed to be done. Couple acts that protect us. So where does our protection come from for having clean water? This is kind of the big one. This is the EPA's act to ensure that we've got clean water. And essentially what the Clean Water Act says is that it will ensure or regulate with the intention of making our waters, our rivers, our lakes, our streams fishable and swimmable. And so what the EPA is able to do here is they're able to set allowable standards, essentially saying what we tolerate in terms of water pollution from companies, from businesses, from cities, etc. And they're in charge, the EPA is in charge of enforcing it and regulating it and making sure that people are complying with this. And so this is kind of a very big deal. They've got a lot of teeth with this bill. They can really go after people that are polluting waters beyond our deemable levels. And it's a good act to have. There's been a lot of progress done under this act. This was kind of a response to that Cuyahoga River fire I showed you from 1969. We've got a second act in the same era to concern ourselves with, the Safe Drinking Water Act. And so again, this act is ensuring kind of the water going into our houses now, where the Clean Water Act is ensuring or regulating the water leaving businesses and houses. This is going into, it sets the standards for drinking water, what we can call clean drinking water in the United States. It doesn't cover wells that have less than 25 people attached to them. So if you have a little private well at your house, it's not regulated under the Safe Water Drinking Act. But city water would be, larger well systems would be, and again, they're setting their pollution tolerances here. Two main ways for water purification. We've gone through sewage treatment enough, so I'm not going to speak about it. There's a whole video dedicated to it. The other type is through septic tanks, and this is a septic tank diagram. Essentially what a septic tank does is it is a large storage bin buried underground. All the wastewater from the house enters that bin. There is an outflow level, and so we'll take water out of the tank and allow it out into a drain field, and then that drain field will slowly let the soil absorb the water and slowly let it dissipate out. And so the goal with septic tank essentially is to have those good bacteria, the decomposers, inside the tank, breaking down the waste that we put in it. And what they do is then they release that waste in the form of excess water that we're putting into it, and nitrates and phosphates and other chemicals like that, which get filtered and percolate down through the soil and eventually enter the water table. Periodically, you're supposed to remove the sludge in the base of the tank and the oils that collect along the surface to maintain a healthy septic system, but it's essentially kind of this self-contained system, but we're relying on the biological process of bacteria to break it down, and then the mechanical process of the soil to filter it out as it moves down. And we really count on it in the case of this house because we've got a well right here where we're drawing that water table water right back up to the house. And so hopefully our septic tank's running well and we're not getting any of those coliform bacterias or other disease-causing bacterias down into our well. So thank you for watching. Please bring notes and questions tomorrow. You might want to look up some of those diseases. I think it would be important to know what kind of diseases are associated with water pollution, especially via the wastewater. So take a minute, look up a few of them, and bring them to class if you can. Thank you for watching, and have a good one.